Welcome to our Riverview labs. This is administration building of Riverview Hospital, which the fourth floor is dedicated to researchers, including my labs. We can walk upstairs and I'm going to take you first to TMS lab, and then EVestG lab, and then a sleep lab. This is our rTMS lab, which is short for repetitive transcranial magnetic stimulation. This has many applications for treatment of neurological disorders, concussion, or mental disorders. However, in this lab we have applied it to concussion, and as well as we just finished a large clinical trial for treatment of Alzheimer's. What it does is that the patient sits here, we put a coil, either active or sham, placebo, they both are identical, over the scalp of the patient, while the MRI of the patient is in that neuronavigation system that acts like a GPS of the brain. Therefore, we can localize the coil over the target area using the MRI of each individual patient, so we know where we are exciting. Assuming that here is our patient, we hold the coil. Of course, we use this handle to carry the coil because the coil is quite heavy. And then after we localize it using the MRI, we give the pulses. During the treatment, we make sure that the coil, the target area, is within the target that is desired, always matching it with the MRI and neuronavigation. This is our acoustic sleep lab dedicated to sleep studies. Established as of 2019 with a CIHR and NSERC funded projects. We have this room is dedicated for sleep studies because we work on sleep apnea detection, diagnosis, and even we are ambitious to know the pathology of the sleep apnea. However, since my work is with sounds and acoustic on top of polysomnography facility that we have, we also record breathing sounds, and that's why that the quietness of the room is quite important. Therefore, this room is sort of anechoic. Of course, it is not doesn't have a very high depression of the sounds. However, it makes it much more quiet. So the patient goes to the room, we connect the patient with the PSG. This is a polysomnography. This is actually the same polysomnography PSG device that is being used in sleep studies, like Mr. Cordia's sleep lab. It has up to 16 channels of data that we connect electrodes to the patients, and then they put it in their neck and go to bed. In addition to this one, this is our own custom designed acoustic recorder. In fact, the actual box is only this one. It is capable of recording 2 sound channels with high quality. We record tracheal sounds in particular, and if there is room on the chest of the patient, if we can, we would also like to record lung sounds. And this device is capable to record for 8 hours non-stop, then transfers the data either by Bluetooth or by USB. We also measure the cross-section area of the nasal cavity by the rhinometer, by this device. And once we have done all our measurement and connection to the patients, the patient goes inside, or the participant go inside the room and sleeps. There is a camera connected to the computer. The sleep tech sits here and observes the participant overnight. Mind you, at the moment we are also running another project which is investigating the effect of a new blanket that claims that it can block electromagnetic field. That is a current study that these days, nights basically, are being run. Overall, Riverview has a very serene environment, including this lounge room that is almost a perfect area for people to wait for their participant patient while they are being treated. Now we are going to go to EVestG lab, which is short for Electrovestibulography. We may have a participant recording today. This is a lab that, in collaboration with Australia, Neural Diagnostic, which is a company that holds the IP of EVestG, and it is the invention of Professor Brian Litko, my colleague.
The idea is that there is a link between the balance system and the emotional behavioural parts of the brain. What we're going to do is to place a small electrode close to the eardrum and then a reference electrode on the outer part of the ear canal and a common on the forehead. And we do that to both sides. That allows us to measure asymmetry between left and right sides, which is often a biomarker of depression or anxiety. And the actual firing rate or neural activity is an indicator of Alzheimer's and or depression. And the shape of the signal that we record is also used as a biomarker to determine individual pathologies as well.